Welcome to another episode of Beta Talk. I'd like to thank my guild patrons who are Primary Pro, Wolsey, Cast Rads, UK Radiators, SB, and Payaka. And you can look up about who they all are on my newsletter website, which is at betateach.co.uk. So today I'm joined by a good friend of mine, Ricky Prescott. Ricky is very well known in the industry. He's very well known for the water quality we have in our heating systems, because we have got a problem with the water quality in our heating systems. We've had a problem for decades, and unfortunately the sort of industry around that hasn't really solved the problem of dirty systems. They've done very, very well selling stuff, I might add. So we're going to talk a bit about water quality, what Ricky does around that to help people, to help educate people. We're going to talk about he's just had a Grant heat pump install, so we're going to be talking about that. He did that himself. So welcome to the show, Ricky. How are you doing?
I'm good, thanks, Nathan. Thanks for having me back on. It's been a while, hasn't it?
It has been a while. We chat most weeks on the phone, don't we? So
Yeah.
you just had. Where did you put your heat pump in? Did you go through the winter?
I've done a winter, so I think Rob Dyer from Grant came out like just before Installer Show last year, so 11th of June last year. So it's coming up towards a year now.
So
it's done me quite well.
I suppose the first question is, how was it?
Well, I've been getting money back from my electric bills, so energy's come down. The house is lovely and warm. It's not really changed the house because I've always ran low temperature gas boiler that was always like locked at 45 degrees anyway. But yeah, it's saved me money. Kids don't like it as much because we have to program our showering strategies, but it's life and it's like the olden days, isn't it?
Well, you got a teenage daughter like me, haven't you?
Yeah, she likes to hang around in the shower and run the water out. I like to have cold showers.
So there's a Nesta initiative called Start at Home, where an engineer gets all the heat pump kit via the bus grant, and then obviously because they put it in themselves, that they essentially doing the labour, so they got to pay for no labour. And the point of that initiative is so they kind of learn, they've done the heat pump training, they learn how to put a heat pump system in, that they're living with it, so they can tweak it, work with it. And so that then inspires, or hopefully inspires them, encourages them to go out and be confident when they install other heat pumps. Now, you didn't do it under the Home Start, did you? You just...
No, I used an umbrella scheme, so wanted to do it just so I could keep my eye. I always say practice what you preach, so people are ringing me up about low temperature water quality and low temperature systems. So I always thought you've got to do it, haven't you? So I thought I can do it in my own time. So I managed it in a couple of days' labour, and I just thought, yeah, I'll get it in. And I just about covered it, I think, within the grant money with the radiator changes and all the pipework cylinder. And it wasn't, I wouldn't say it was a hard job. It was harder for me because I'm not on the tools that often. So it was, I think when I timed it all, it was 46 hours labour for pretty much everything, digging the feet into the ground to all the trunk in the pipe work, because it went up from the outside, so it sat outside the back kitchen wall and it went up and trunking up the gable end. Then I had to take the roof tiles off and run it in the roof pitch because it's like a hip roof. So I ran it into the loft space, and then I had to cut all like the loft hatch open to get a cylinder in, board all the loft properly, support it all, and yeah, get everything. But my hardest thing was like sourcing materials, because no one around this area tends to do much over 22 millimeters, and trying to get kit was a nightmare. So Grant supplied me direct with the heat pump. That was through the installer program thing, the first one. They give you a discounted rate, so we got that at a discount, and that was it really. It was just pipe and fittings, and it was, everything was just difficult to get. The local plumbing branches, you went in and asked for, like, you'd ask for Primary Pro, and they're just oblivious to it. They wouldn't have a clue.
And you said they don't stock 28mm copper?
Some of them did in press fit, because they use press fit and they use a lot of MLCP. So I wanted to run one run from the back of the heat pump straight up and to the 3-port valve with no joins. But if you ever try wrestling 32mm MLCP on a pitched ladder that's virtually vertical on your own with no one helping you, I had to put one cut in it. But it's all the fittings, because you're using MLCP, no one stocks it locally. You've got to mail order it, but then you need to mail order extra just in case you run out, because at 10 o'clock at night when you're still grafting after you've done your day job, to be one fitting short is pretty disappointing. So you end up with extra fittings, extra costs.
And there was quite a lot of fittings, would you say?
Not really. Yeah, not loads of fittings, but I always like just think, I'll just buy a box of that, a box of this, instead of just thinking, oh, it's going to be 2 elbows there, because it's always better to have them. To me, it's better to spend a bit of extra money than have extra fittings than be short at the middle of the night when you need it and run out, then have to wait the next day to mail order it, the next day for it to get delivered. So you do lose loads of time that way. And that's the hard thing about, I thought, with people getting into heat pumps is you need support from your local merchants. They need to stock all your stuff. Otherwise, you sit up all night just on mail ordering from various different websites and getting different fittings from here, different fittings there. And I think a lot of big merchants are coming onto it now. They're stocking a lot of stuff. If people want heat pumps, they'll keep them, cylinders, all the valves, all the fittings. They tend to stock it all now. There's been a big change in the past few years, hasn't there?
Yeah. I mean, so what was the so if you were to name the one thing that sort of really, really surprised you about the install, what would that be?
Just the plumbing side of it's easy. It's all the surprises, isn't it? You've got to think the planning. You've got to how you're going to get your pipes up to the lofts. We went from a combi under the stairs downstairs to a unvented cylinder upstairs. So we had to get a decent sized cold main up, then the hots back down, the D2 back down. So yeah, you just got a bit more care and consideration with your planning. Really, I had to cut a stud wall out, like take the plasterboard off it to get all the pipes in it, then put that back on. Then that wall also had a tall vertical radiator on it, so I had to be careful where I put the pipes with the brackets and thingy. But it wasn't a difficult job. It was just, it's different, isn't it, than a general plumbing job? And that's all we are. At the end of the day, people are just plumbers, and that's all the industry needs: people to put pipes in floors and walls and hang radiators.
Well, talking about radiators, you had to K3. You put a post on about your K3. I don't think you liked it to start with, did you?
So the good thing about it, I took was it 1800 K2 off Stelrad, and I struggled. The merchants dropped it off for me, so I humped it in on my own, got it into the lounge, and then they just look big and ugly, don't they?
Well, I remember that post. I don't mind them. I don't. I've never minded the looks of radiators, and
the good thing is it acts as like where I can put all because my desk's next to it, so I just put all my files and paper on it, and it keeps them all like straight.
What temperature is your system running at?
I don't think it got over 35 degrees all year, so it's 10 degrees under design temp, I think.
So I just want to reiterate that for listeners. Even in sort of the midwinter, the water temperature in your radiators never had to be over 35 to heat your home.
I don't think so. When I looked, when we had the -5, -6 blip in January, I don't think it ever went near 40. And so when I designed it, I used Heat Engineer, and then I went on to Spruce and done the sizing through the Spruce because it had all the MCS thing on the side of it. And yeah, the radiator sizes were a little bit bigger. K2s just had to double some up, didn't have to do a lot of pipework alterations. And yeah, it said 45-degree flow temp, and it sits at like 28 most of the year, 28, 32.
So without some radiator changes, your home would have been able to heat itself up easily, but just with a higher temperature, when it probably around 45, 48 maybe.
Yeah, I think so. I think if I'd have just chucked a heat pump in, come straight down that wall from the 3-port valve into the circuit, I reckon it would have been fine. And it's a 1930s solid stone, so I've no cavity wall, no insulation, loft's insulated, and that's it. And just leave it on.
See, this highlights quite a big problem actually, and a big challenge, and one of the reasons why sort of one of the strong myths is still sort of pertaining to, and that's because historically everyone is used to running heating systems so hot. You know, back in the days, the 50s, 60s, 70s, we had to run them hot to protect the water jacket from condensate. Condensing boilers come in. And unfortunately, in our country, we've never been wiring them up properly to the proper bus terminals.
No.
We're still using switch live on the PCBs. And that means there's this mindset that radiators have to be really, really hot. And they don't. You know, if it was -5 outside, there's quite a lot of houses that would probably need 65, maybe 70 when it's -5 outside. But
Yeah.
most of winter, you're dropping drastically down into the 40s. And like you've just found, you've had a few radiator changes, yes, but you're not even going over 35 degrees. So actually, you're below body temperature, so you probably don't even know your rads are on after
Yeah.
night.
Yeah, and everyone's like, people talk about balancing. I just found it hard to balance as well because the radiator temp's that low. Your room temp's at 20, 21. It's hard to drag 5 degrees out the radiator flow and return when the room temperature's that and the flow temp's that low.
Mm.
It worked. And like I say, I had a gas boiler previous, and that was low temp, locked. I had an Alpha E-Tech, and that was locked at minimum, which was 4.2 kilowatt output. So that I had that locked at minimum, and that heated the house. So when I done the heat loss, it coming at 6.1 or 6.2. So I looked what was on the market and ended up, I thought I'd go for Grant. I've got quite a good relationship with Grant. So I went with 6.5. Is it Arona 290?
Mm-hmm.
Yeah, I went with that, and it's worked well since.
And I mean, do you sort of like do what lots of others do? You sort of fiddle and tweak and just
Never tweaked it. I had an issue with the pump pulsing as we were coming out the shoulder months into the winter. It was just having a bit of a hissy fit when it was firing. The pump was just circulating a bit. So I rung the Grant up, and they just sent Alex out, an engineer, and he come out with an SD card update, plugged it in, and it's been fine since. But I know a lot of people are playing updates, getting cards, updating them, changing settings, and struggling with the efficiency on them. Rob Dyer came out, we plugged it in, turned it on, and left it. I've messed around with the weather comp to see how low I could get it, and I could probably get it a little bit lower, but it's always been.
And price, what running costs for your Lecky build been nice.
Don't think we went over £5 a day. So I've got an energy clamp on it in the loft, so it's monitoring. Everything goes up to the loft on one from the consumer unit, and then there's a secondary consumer unit up there. Then everything's fed off that, and the cable that runs into that's got a monitor on it. And I think it was a £5 a day at the most, 5.50 maximum. So 1 pint of beer, that's it, or a cost of coffee, and people moan about it, cost of electric when they're stood in a pub.
Yeah, cost of. Well, perhaps I should mention cost of all coffee shops.
It's dear, isn't it?
Yeah, it is very dear. So, Ricky, I imagine you've possibly got the cleanest heating system in the country. What do you reckon?
I would say one of them. I did test it last week because I've got a PowerPoint thing to do at manufacturers next week. So I tested this water. And when we test water with my test kit, it's got an Fe10 reagent. So we drop central heating water and put these drops of reagent in. If it's clear, it means there's zero in it, zero iron, which obviously you've got iron radiators. You usually, inhibitor systems, it tends to go pink or purple. But with this one, I use the photometer. So it's a computer, and you put the reagent in with the water, and it scans it. And it wouldn't pick up on an FE6 and 8 test. So we had to change it to an FE5, which is a low range. And I think there's like 0.02 parts per million of iron in it, which is pretty low.
So just for the reader, you're taking a sample and you're putting that sample in some sort of receptacle, and then you drop your reactor agent into it, and then you test.
Yeah, so the basic test, we have a color comparator chart. So it's like several bars of pink, and the more pink it is, the more parts per million of iron you've got. So you've got active corrosion going on. But I do have a computer where I drop it in. It's like a photometer, sends like light beams through it, scans it. And I literally have to get some more reagent just to monitor, just to get a reading on it's that low.
And then obviously you're doing conductivity test.
Yeah, conductivity slightly higher than I want, but I've got 2 radiators to take off and decorate, so I've cleaned it up again. That was 106 microsiemens, and the pH was 9.2, I think. So it's all perfect, really, for an iron system.
And of course, for the listener, this is the methods you're using the VDI 2035 methods, aren't they? Which is
That's right. Yeah, yeah.
and for anyone that doesn't know, the VDI, I can never remember what it stands for in German, but basically it's a bit similar to our British Standards Institute, except that it's not the same. So our British Standards Institute tend to be made up of working groups, and those working groups tend to come from manufacturers. So, like for instance, the British Standard 7593, which is all to do with water quality, that was basically written by all the manufacturers that are involved with magnetic filters and chemical inhibitors. Whereas the VDI, which is they set standards over in Germany, and it's academics, it's material scientists, it's engineers. It's not really anyone with a commercial interest. And they set 203, that they brought that standard in because, ironically, the German manufacturers Bosch, Buderus, and Valent and Wiesmann found and discovered back in the day that when they switched, when everyone was switching over to condensing boilers, that the heat exchangers, which were starting to use things like stainless steel and aluminium, were corroding, and it was the inhibitor that was corroding them. So they thought, well, when you put an inhibitor in a system, it's sort of kind of masking the problem in a way, isn't it, Ricky? But whereas if you take the minerals out of the water, you've got a solution, and that's what the German standard wanted. Now, ironically, those same, well, not Wiesmann, Mick Wiesmann have done quite well, I think, on the VDI and promoting that.
Yeah, they were chemical-free systems.
But we've got this really weird scenario in UK where boiler companies, they have their manufacturer's instructions. They kind of put their warranties against, a lot of the time, BS 7593, which limits engineers. Well, no, it doesn't limit engineers. I mean, we've got this problem going on at the moment. AD and other chemical inhibitor companies are saying that chemical inhibitor is mandatory. It's not. I think they need to realise what the building regulations actually are.
Yeah.
And also the Building Act 1984. They've got no idea, I don't think, how to interpret the regulations properly. They just, and this is the other thing, when approved documents are revised, they bring in and they get working parties. And again, a lot of these working groups are made up of manufacturers with commercial interest. Now, I'm not saying they do it on purpose, but what I'm saying is a lot of them aren't, A, they're not that technical, and B, they just definitely
they should
interpret the
Me
regulations.
personally, they should have like HPA have done. Obviously, they've got Damon Blakemore for the installer side of it, but I think a lot of these standards, they should get working groups, like people, not like myself. Obviously, people say I've got a vested interest. I won't go on any boards or anything anymore. I had an issue with one a few years ago. So, but they should get people who are on the tools and invite people who are running companies and the dealing with it every day to help with the standards.
Well, you were in the water quality group with the HHIC.
HHIC, I was part of, and
but they weren't inviting you to the meetings, were they?
I didn't get invited to any water quality meetings. I got invited to some of the installer things and bits and bobs with DesNets when they were talking about energy. I think it was probably the time when the war had just started in Ukraine, and then I found out I didn't get invited to the water quality meetings. So
even though you were paying your membership fee,
yeah, I asked for the minutes for the meeting and I didn't get them, and I just decided I don't want to associate with Thoroflush with that.
And I suppose for the benefit of the reader, that's because you are widely known in the UK as being the expert on sort of VDI 203.
Well, yeah, I questioned the chair of the benchmark about inhibitor and how they can test for. There was no test regime for all inhibitors, and the company that they worked for, I think, recommended an inhibitor that didn't have a test regime. And I was like, well, how can you fill your benchmark in if you can't test for that inhibitor? And yeah, I don't think it went down too great. Not sure what happened, but I'm just telling the truth, really. How you can't tell people they've got to do something when you can't. You've got no one provides the equipment to do it. If you know what I'm saying.
It's quite strange because I think for the first time in history, so we've got an approved document that's sort of had some revisions. We've got the 2026 one now started, but I think it may be for the first time, if you follow the guidance, you actually break the regulations. So there is a regulation within Part L that it's all to do with commissioning, that you have to test your systems, and the whole point of that is to make sure you're not using too much fuel and power. And now they've revised it also to greenhouse gases. So when the chemical companies did their British Standard 7593, which is mentioned in the approved document, doesn't mean you've got to follow it. There's no law to say you've got to follow it. It's that, like you pointed out, when they wrote that standard, there's no real standard way of testing the water quality. You can test an individual manufacturer's inhibitor, but you can't really. There's so many inhibitors on the market, whereas VDI, there's just a standard test procedure that
Yeah.
fulfills the regulations criteria. The requirement in the regulations is that you be able to test your heating systems, all sorts of testing. And of course, they've written a standard which actually possibly prevents you from testing.
Well, the other thing is the British standard in section 10 of the BS 7593 2019, it says to test for additives. It doesn't say inhibitor, it says additives. So at commissioning, you've got a test for concentration of additives, and every year thereafter, I think that's the words. But look at biocide, you can't test for it. I spoke to Fernox a while ago, and she said, "Oh, there's no test kit for it." I said, "Well, that is a non-compliant product. Then you can't. If you can't test for it, how do you know how much to put in?" And she said, "Oh, just put a new bottle in every year, but don't overdose it." I was like, "Well, if you don't know how much is in it, and you put a new bottle in every year, how do you know you're not overdosing it?" And I was like, "It's just like a document that's written." And I don't like to say it because I manufacture and sell stuff as a business, but it's like a document that's written by companies to sell products. There's no information that's useful for an end user in that document. There's one water parameter that I keep saying it that says hard water is 200 parts per million and above. There's nothing that says what pH we recommend in heating systems, what iron levels, what chloride levels. So if you sent a lab sample away to a lab, it'll come back with all these parameters in it, like Fernox to say pH, conductivity, hardness. There's none of that referred to in the British standard. So why not put that in the standard? Why don't they make a standard document, what the labs expect to see in a system? And then we can then provide test kits to test for that in a system. But they just say, just test for inhibitor levels for the benchmark.
Well, of course, that's problematic because different inhibitors use different. So most of them use molybdenum. I can never pronounce it, Ricky.
Molybdenate.
Yeah.
Yeah.
So the other ones are Others types are nitrate based, aren't they?
Nitrate and nitrite. Yeah.
And of course,
we do have blends of other products in there to like stabilize. You try and keep the pH in neutral. Some don't, but some of the bigger names will keep the pH in the region of the fill water.
And another thing that people probably are not aware of. So I was asked quite a few years ago to go down to AD. Basically, I provided them free consultation, and I took a handful of engineers down with me. Ricky was one of them. And we went in the lab. We've got some lovely equipment in the lab because AD are also a UCAS test centre. So they've got accreditation to test inhibitors. They're the only one in the country. And so what they do, they're allowed to do it, they test, they're constantly testing, and they're constantly testing their competition's inhibitors, the same people they wrote the British Standard with, and they're testing them to actually corrode metal. So we saw all the samples, didn't we? We saw the pitting. We saw.
Yeah, they wouldn't tell us whose was whose, but you never know whether it's a marketing.
Well, I wasn't actually that bothered whose was who. What it's suggesting is we've got a whole chemical inhibitor industry that comes together and basically, as a united voice, says, right, everyone, it's mandatory to buy inhibitor, which they've got wrong for a start. And BEMA are the trade body that sort of represents some of these chemical inhibitor companies, and they kind of, I think, say the same, or trying to say the same, inhibitors mandatory. And yet the irony is, the UCAS centre is testing in lots of inhibitors that it's actually corroding metals, which is what the Germans discovered 30 years ago. I think is when they started to change over the ways of preventing corrosion in their system. And we've just got this massive industry. It started from good beginnings. Fernox, when they started, we had problems because heating systems had to run very hot to protect the boiler, to protect it from, any water vapor condensing out the flame and destroying the water jacket. So we kept systems high. When you have a high temperature, it increases the rate of corrosion. So when inhibitors came on the market, they came on the market shelves the year I was born, 1971. There was a good reason they came around. But like anything in this industry, if something sells, then everyone wants to make it and sell it. So we've got big companies out there making a lot of OEM product for.
I think that's when inhibitor died, didn't it? It was meant to be. Someone told me who used to work for Fernox that when the marketing companies got hold of it, that's when the concentration levels dropped, and it just become a 5-6 quid a bottle market then. And now it's even less than that, isn't it?
How many makes do you think are out there at the moment, Ricky?
There's a couple of big players. You've always have your AD.
How many labels? I reckon we're up to about 40.
Yeah, there's loads of things. You've got a lot of own labels now. Lettergold make a lot, like the Flowmaster, Camco, BES, Cura, Boiler Mag, is it? Wicks being there's a few brands that so Lettergold are a big player. AD, Fernox. You've got your major brands, haven't you? When you go into a merchant, you're always going to see your three major brands, which are your AD, Fernox, and Sentinel.
They pay the national merchants to be forward facing, so they pay.
Yeah, I don't know. There'll be some kind of structure
on the front shelves.
And they all use molybdate. The problem is now it's like a lot of your City brand are using Scale Master, City Plumbing, sorry. Your Instinct brand, which is like your Poachings, is it? Not UKPS, IPG Group, is it? Possibly. So they use Scale Master, so they're a different ingredient that doesn't use molybdate. So it's a minefield out there, isn't it?
Yeah. The other interesting thing about the regulation, so Part L has changed. So the regulations are 2010, and they make amendments. They can make amendments to them. They're still the build regulations 2010, and they obviously make amendments to the guidance. Now, the title of Part L has been Conservation of Fuel and Power for quite a long time, but they've now added the greenhouse aspect to it. So we want to see reduction of greenhouse, and this is interesting because we're going to get. I think Beamer are doing some webinars soon with Installer, and obviously ADIA email, and you got the email, didn't you? ADIA saying that chemical.
Yeah, I sent an email, for the company I used to work for, yeah.
But the interesting thing is, we are now supposed to be reducing greenhouse gases. We are selling millions and millions. I don't know if they're single-use plastic bottles. I can't remember what the code is on the bottom of them. But you and I know well enough. You go up in people's lofts. I've seen loads and loads of bottles of inhibitor.
Oh yeah.
These plastic bottles constantly getting made, so that obviously there's a carbon cost for making the plastic bottles. Now the method you use, VDI 2035, you use resin beads. Now your resin beads are you can regenerate.
You can regenerate them, yeah. The problem is people think VDI 2035 is a product. There's no products involved with it. Like you go up to Scotland, someplace in Birmingham, Wales, you could fill with tap water if you wanted. It's all about monitoring the water.
Because it meets the test criteria.
It's some of the, I know parts of I've got customers in Cornwall that show me a lot of corrosion problems they're having, but all their systems have just been filled with tap water, monitored, and they're crystal clear. But they go to other systems rectifying a lot of eco jobs, and they're all like bloody syrup. It's like soup. It's horrible.
And that's because they're the ones that have had
They've had all kinds of chemicals. They've probably had cleaners left in them, biocide, glycol, just a recipe of everything that no one wants to put in a system in.
And this, this is the other problem we've got. You've mentioned chemical cleaners. So if someone uses a chemical cleaner, and as we know, chemical cleaners can work quite well. But the trouble is you have to get every single bit of that chemical cleaner out before you then
I would recommend
add the inhibitor, otherwise they react with each other. Now, you and I are heating engineers. It's hard to get. If you fill up the system, you've got pipe work going here, there, everywhere. It's dropping down to all your radiators down below. A lot of radiators don't have drain points on each single radiator. So it's very, very hard to get traces of that chemical cleaner out. So, of course, and you and I know that most heating companies aren't doing it. They're not sort of going in as conscientiously as you would, trying to flush it out completely.
Oh, majority will be bottle a cleaner in because the rules say to put a cleaner in, leave it in for an hour, drain it off at the hallway radiator, put an inhibitor in and walk away. No one's, even if you then tested for concentration of that inhibitor like the British standard asked you to, you're still doing what it asked you to. You're still doing your job right, because it's not asking you to test for the water quality. It's asking you to test if there's enough inhibitor in. And I know some of the big players, AD and Fernox, said that their inhibitor will work satisfactorily with like 15-20% of inhibitor cleaner left in, if it's their cleaner.
Yeah, but that's the point. If it's their cleaner, there's so many cleaners in the market, and their UCAS test centre is already testing inhibitors to corrode metal. And the problem
there's another plastic bottle in a bottle of cleaner, another one.
The problem is, I'm not saying the boiler companies do it on purpose or the chemical companies do this on purpose, but they aren't bothered if stuff breaks down. If stuff breaks down, an engineer goes out and is off to replacing stuff. That's great for them. That's another sales. I'm not saying it's being done on purpose, but the evidence is there. The evidence is crystal clear that our boilers break down far quicker than other European countries.
Mm-hmm.
I get challenged on that all the time. Well, that is why our little country was the biggest boiler, had the biggest gas boiler market in the world up to 2016. It's because our boilers were breaking down and getting replaced. It's not rocket science. We've got a problem with sludge. We've got a problem with corrosion. We've got everyone's going gaga over magnetic filters. Magnetic filters do not stop corrosion. They collect very fine particles called magnetite. The magnetite is basically settling in a radiator because of low velocity. And you're not getting it out the radiator, and that's when you start to lose efficiency. Just the fact that you put a MagnaClean on the system doesn't make it efficient. And yet we've got a whole load of engineers. Great, they're fantastic at getting a gas boiler going again and making it safe. But they've been marketed and bamboozled so much for marketing. They actually do believe you put a magnetic filter on a system, and it's the bee's knees. You've done a great job.
Yeah,
they've got
it helps, doesn't it?
They've got no idea about water velocity, and low velocity and pressure drop, and why sludge stays in a radiator. None of that sludge is miraculously going to a magnet. And I've just written a newsletter about this, which I'll probably release the same time as this podcast, actually. But it's not, there's AD can do such good things. They're a fantastic entrepreneurial story, beautiful entrepreneurial story. And I don't know if you noticed this, but when we went up there, Ricky, there was chemists and then there was marketing people. We met over, 25 people working there. None of them were heating engineers or ex-heating engineers or even doing heating, if I'm honest. They were marketing people, strategy people, and the chemists. And it's a bit of a problem. Because you need clean systems. Now, what you and I have discussed is no one's going to start rushing out and buying the equipment they need for VDI. What would the equipment be anyway? So maybe you need your demineralization kit, you need a test kit.
I would, always start with the test kit. So you need to test your water. What's your filling water? So what are your parameters of your fill water? Hardness, pH is pretty stable across the UK. Conductivity, and then once you've got it up in the system, commissioned, up and running, you test it again, log that data, and then go back every year and check it. And as long as there's been no top ups, it should be pretty stable. Really, you find your water parameters tend to be more stable with low temperature. Your conductivity will stay more stable. Obviously, if you're filling with tap water and you've got high conductivity with a gas boiler, you can cause a bit of scale on the heat exchange, and it's not a massive issue. It's repetitive top-ups that are causing the problem. So
now, I know you used to keep up to date with this a few years back, but do you sort of keep up to date and have a look around at what boiler manufacturers are doing in their warranty and manufacturers' instructions? Are there some that are there some saying that you can't use VDI?
Valent had Valent 20 when I launched it. I think they kind of got a bit edgy with it. But I think I have seen a document from the reps from Valent saying that it's satisfactory to use it. You've just got to label the system.
Well, Valent was one of the ones that asked for the VDI 2035.
Yeah, and I think that's the problem is lack of awareness in the industry. So label the system up. If you are filling with deeming water or tap water, just state it on the boiler so you can get stickers made. With your own logo on.
Do a lot of alpha boilers. What were they on their manufacturers? Right?
They weren't bothered. Yeah, every alpha I put in, I reckon it's had a diverter valve in it, and every alpha I snuck when I was testing it with the old company I worked for, chemical free into. I reckon that's never had a diverter.
So basically, just for the
they would pop. It would rip the seals out of them for fun. All of the inhibitors. I didn't know much about it before 2018, so we were just lashing up because it says put a bottle in. It doesn't say put half a bottle in, does it? But
and that was the diverter valves were breaking.
Yeah, the seals and they were Grundfos hydro blocks as well. So they were obviously inhibitors are tested for a certain rubber. So when they go for the NSF test in the glass jar, it's a certain grade of rubber that they test for. So is that, you don't know whether all rubbers are tested with that procedure. So that's another thing. Inhibitors tested for about 200 and some hours in a glass jar. It's not replicating a system, really, is it? And
it's pretty common sense, is it? If you've got lots of materials in a heating system and they're metal materials as well as other materials, take the stuff out of the water that causes corrosion, and that's minerals, that's mineral salts. Because if you've got mineral salts in your water, like calcium carbonate, stuff like that, you provide an electric path. The water becomes an electrolyte, and that's what enables corrosion. Take that out, it drastically reduces corrosion. Now, in our country, we try and master the problem by we've got chemists up and down the country that for years and years and years are tweaking the chemistry. I mean, we've met the top chemists, tweaking the chemistry, and it's just putting a plaster.
do you know what? It's all well being open vented, chuck a bottle of inhibitor in, work out a bit of system volume, dose it correctly. You won't go far wrong. But oxygen, I keep saying oxygen's the killer, and we need to get our in our brains. You remove oxygen from a system, everything disappears. If you get your expansions charged, your expansions correct size, pumps in the right place, sealed, not many top ups throughout the year, oxygen will disappear through the corrosion process as the passivation starts, and then your systems are fine.
I mean, our boiler industry's got so much to answer for. I love our boiler industry. My family was part of the boiler industry. But
yeah,
grandfather was importing and developing the burners for two of the biggest boiler manufacturers at the time for their oil, Trianco and Bosch, Worcester back then. But with the gas, I mean, I actually had a meeting with Offtech today. They came out to meet me. I met up with Malcolm, who's a very, very good friend of mine. So my granddad wrote Offtech's first standards. So, now oil have got quite a USP compared to gas boilers. So oil you've never been able to modulate. So even though they make oil condensing boilers, so I'm always banging on about how boilers haven't been controlled properly, the gas boilers, because it's just modulating the flame like you do on a gas cooker, but we don't wire them up properly, so they do that. So the gas boiler industry hasn't really told people how to control them properly. Now, oil could never modulate. We have now got the EOGB, which was the company my grandfather co-founded. Martin Cook there, brilliant guy, brilliant technical director. He's now managing director. They have built the first, I think it's the first in Europe, fully modulating oil burner for their boilers. But historically, oil, they weren't telling people to do it wrong, if you know what I mean. Whereas gas boilers were just keeping quiet. The gas boiler companies were keeping quiet on how to control boilers properly. And the oil industry didn't do that. I mean, they've got some really interesting USPs, the oil industry, which I'll be writing about very soon. I won't sort of give them all away yet, but and they've got great engineers. That's the other thing, servicing. With oil engineers or boiler engineers, service the boiler. You have to. You clean your baffles out. You change your nozzle. Predominantly, the gas engineers that are working for the big companies like British Gas, HomeServe, HomeTree, all these big entities now that people are paying their 40 quid a month to guarantee they get a service a year and maybe break down.
It's become a safety check.
They're not servicing their boiler. They're not servicing the boiler. They're just doing a safety check. So if you're a landlord listening to this, you'll get a blue ticket called a CP12. And that's actually got a tiny little line saying, did the engineer do anything extra? And it's got EG service. That kind of tells you that what they are doing is just a safety check. They go in, they check the flue, they do a combustion analysis. If that's okay, off they go. And a lot of the people that are working for these large service contractors are getting cajoled to do as many as possible, up to 20, 25 a day, which is ridiculous. Whereas the oil industry, your engineers go and do a proper job. They're sort of cleaning it out. Well, most of them are doing a proper job. They're cleaning it out.
You have to, didn't you? They wouldn't work.
Yeah. So there's some really good things that have come from the oil industry, and I think we can really work with their engineers.
It's like I always say to people, water quality spans from an expansion vessel. Like your general day-to-day property, 3-bed semi, get ideal logic, backseat, whatever. If you charge that expansion vessel, you don't really get many issues with water quality. The problem is high temp systems swinging, auto air vents fully open, half flat expansion vessels. They're up and down. They're up to 2.5 bar, then back down, up and down. They're dragging in air wherever they can. Pumps are probably on the wrong end of the thingy. Expansion vessels are straight after the pump on some of them. So they've got the pump out expansion vessels. So that when you fire the boilers up, the pressure gauge drops down. So like it's sucking.
Well, unfortunately, a lot of engineers out there don't know the science around expansion vessels, which is a shame.
I don't think any of us do. Have you ever met Derek from IMI?
Yeah, lovely, Derek. I've been out for a good meal.
Cracking bloke, but Jesus, when he gets going about expansion, you're in another. Have you seen the IMI's hydronics book?
Yeah, yeah.
Everyone on LinkedIn thinks they're experts until they've read. Give them that book, and it's a different.
Well, it's like anything with maths, and it's like thermodynamics. You can go right down that rabbit hole if you want to. I mean, you don't have to go right down the rabbit hole.
Do you know what I think with this industry? It's the basics, and get your heat loss right, get your radiator sizing right, a bit of pipe sizing, and we're away. Rule of thumbs are coming.
But that's not what's happening. So our industry, it tends to be trained by marketing, and which is what I did at Nesta. I did a big talk about this. People talk about the skills gap. The skills gap is actually a symptom of communications gap. So all the engineers, most engineers are being bamboozled with marketing messages. So like the magnetic filter is probably the epitomizes, is symbolic of how we've been bamboozled with marketing. Now, great entrepreneurial story. Chris Adey was a gas engineer, started that company up in his shed because he went to Fernox and said, "Can you help me develop this?" They said no. So he did it all on his own. It started to sell, and like anything, when other manufacturers see something selling, so there's now loads of manufacturers that make them. Beautiful entrepreneurial story, but it mesmerised us. And ironically, the word mesmerise does not come from a Latin root word or Greek. It comes from there was a guy called Frank Mesmer, I think his name was, back in the 1700s, and he was basically conning people. He would have lots of water. He'd get mainly women, mainly aristocratic women, and he'd get them to sit near these magnets, and it was supposed to cure them of all sorts of things, and it didn't. And I think it was the King of France. I was going to say King Louis, but I think it might be. He commissioned some people to actually research whether he was conning people, and one of them people was Benjamin Franklin, and another one was Lavoisier, I think. And that's actually where the double-blind study first came from, and that's where this word mesmerised. He was mesmerising people into this frenzy of like they believed this was real. Mm-hmm. Also, that some good things did come of that, like they studied the placebo effect. But this is people saw that magnet, and I've talked about it in my latest newsletter. You used to shake that demonstration jar, put the magnet in, and everyone go, "Ooh, wow!" Now, what no one's telling you is the magnetite that these magnets pick up is very, very fine suspended particles, very fine. The sludge that's being the product of corrosion that's happening in your radiators, that ain't going anywhere. That just settles to the bottom of the radiator because there's low velocity in your radiator. And unfortunately, most engineers don't know what velocity is and the difference there is between velocity and flow rate. No one's getting taught this stuff. They just get taught that stick a magnet on the system, and it's the be all and end all because it does look all fancy, and it's a bit like thermal imaging at the moment. I'm a bit worried about that industry at the moment because it looks so good and cool. It's kind of a little bit easy to con people around it. I mean, you've just had before we come online, your was it great aunt or your auntie's just been
my auntie, my mum's sister, just rung me yesterday from Spain. She's just gone away, and she was called by a company, and they came in and scanned the radiators. I told them there's 20% sludge in them. It needs cleaning out. They'll fit a filter, chemical flush, add a chemical, balance it. 1,100 quid.
How much?
1,100 quid. Oh, a bit of a discount for old age pensioner. So this is people out the area coming into different areas. Yeah, a bit of shocking, really. I felt like ringing them up, but
now,
not in a position.
This isn't Adey's fault or anyone else that makes magnetic filters, but they have created this problem, and they definitely haven't done it on purpose. What happens in our industry? You will get entities look for little niche jobs they can do, and because there's been so much fanfare around magnetic filters and system cleaning, you've got companies that will go out. That's all they do. They've got no idea about heat systems.
Oh, if you could go to a customer's house, charge him 1,100 quid to fit a filter, 80 quid, bottle of chemical and cleaner, 20 quid, put it in, fit the filter, drain the system, fit the filter, smash hell out the radiators for half an hour while it's getting red hot, use the boiler circulator, collect the debris, show the customer all this sludge that you've just smashed hell out the radiators and take 1,100 quid home. Crazy.
It's one of the
But
sad.
people believe them because they see that sludge, and I keep saying to people that sludge will be quite happily sat in a radiator, and it's not all. The end game is not about getting the biggest looking thick sludge magnet out sausage.
Well, these magnetic. See, that's another thing. These people that use the magnets for cleaning, again, they aren't
Yeah,
great at cleaning the
I
system.
keep saying to people, it's about creating the environment at the end game. It's not about getting all that sludge out.
I tell you, the thing that really frustrates me, because obviously I hate old people being exploited by any tradesperson
Yeah,
in any trade. I really, really do. Now, there's an issue because I've asked if I think a company is doing that, I'll confront them. I'm not worried about confronting them. But what I found is some of them actually think they are doing a very good job, and this comes back to they've been bamboozled by the marketing. They really do believe. Let's say they actually do believe, right, we're using the same manufacturer, we're using the best manufacturer, let's say, for the chemical cleaner, the best manufacturer for the inhibitor, we're putting their magnetic filter on, we are maybe thermal imaging the radiators and giving a little bit of a survey, some pictures to the. They actually do believe they're doing something useful, and
it's marketing, isn't it? Yeah.
that's that's even more upsetting. I think obviously the real horrible cowboys that go out there and couldn't care about old people and just exploit people for the sake of exploiting them, they're a different entity. But I think there are companies that actually do believe, oh, this is a good little niche, let's get into it, let's learn about it. So they go on the AD training. They don't learn anything really about how temperature increases the rate of corrosion. They don't learn anything about.
No, that's the sad thing, isn't it? You're getting a little training centre for a day, bit of product awareness, how to flush a basic heating system, how to test, give them a results on an app and or a certificate, and say, yeah, it's all protected. But they think they're doing the best practice. But is it best practice?
And the thing is with a company like AED and Fernox, because they obviously possibly do make the best inhibitors. If one of them was brave enough, and this is the thing, they've got new strategists because they got bought out in 2021 for about 210 million AD from Polypipe, which is owned by another company. Can't think of them. Genuine, I think. And I think the people that were working there had to work another 5 years because they've all gone now. Most of the people there I knew have all gone. And so they got all new strategy people. And this is a time, I think, for them to have a real good sit down and a think because they've got, if someone was to ask me, Ricky, who in this industry is best placed to inspire engineers to learn and to make the industry better, I wouldn't name a boiler manufacturer or a heat pump manufacturer. I'd name someone like AD because they're not a boiler manufacturer, so it's not their fault. Boiler companies weren't telling people how to control boilers properly, and we've always had high temp systems. No, that wasn't their fault at all. But they're in a position because they are powerful. They have one of the biggest stands at Installer Show. They've got a lot of engineers that subscribe to them, because you have to sign up to their email thing when you buy one of these MagnaClean sort of thing. They've got the ear of the engineer. If they were to teach engineers some certain stuff, and I can help them with that, the engineers aren't going to all run out and buy VDI equipment. They're going to, but what they might do is think, oh, that company AD is helping us. We're learning so much stuff from AD about how heat pumps work, maybe have flow rates and velocities. They're not going to run out and buy VDI, but they'll, because AD's being honest, they'll buy their inhibitor because it is more expensive than most of the cheap brands you can get. And you don't see companies doing this. You don't see these big companies thinking, right, let's just create a blue ocean strategy for ourselves. Let's put our head above the parapet. I've always said Hive could do this. Hive could put their head above the parapet, say, look, we have got it wrong. It wasn't really our fault. We were just designers and people that come into the heat industry got told to make something nice UX design. It wasn't our fault that the boilers weren't telling everyone how to control their boilers properly.
No.
If they held their hands up, said, we have got it wrong, guys, but we're going to do it better, and we're going to help people understand what we should have done in the first place. None of them do that. None of them do that, and it's so sad. We're in this most competitive market in Europe.
It's a shit. The whole industry, they're all owned by investment corporations and groups, and investors want money back. So they've got to hit targets and sell products, haven't they?
Mm.
And that's where it's just me and Thorough Flush, and I'm happy just plodding along. And I'm going to start the Ricky Road show soon. We'll just do a few training. I've got this thing to do at manufacture next week, and then that'll kick me up the backside to get out. And it's not going to be a bit of that Thorough Flush, power flushing, Magna cleaning.
No, I'm not going to mention their name, but there there's a power flush company, because obviously they're trying to sell power flushes, who are trying to tell me, because I recommend your Thorough Flush. That's what I would use.
Yeah.
What I do use if I'm not on the tools anymore. Everyone's used the power flushing thing. They came out years ago, didn't they? And again, companies were setting up just to power flush and making lots of money out of it. But they don't. I don't think they have got a use sometimes, but I don't think they're anywhere as near as good as your equipment.
No, I'm a great believer of pressure.
The Magna Cleans. Let's just talk about. So the magnetic filter, yeah, put that on a heating system. They then devised that cleaning system, which is basically massive magnets. But what that's relying on your circulation pump in your heating system. Now, the last thing you want is crud going into that system, that circulator pump. So they've developed a cleaning system that wants the sludge and horrible dirt to go through your pump before it gets to their great big magnets. It makes absolutely no sense whatsoever.
It should go through the magnets first, then the circulator.
And of course, circulators now, the ones that controlling with temperature and modulating down, you're going to get no flow rate. So
yeah, you'll limit the flow rates on a standard house 10mm microbore. You're going to, when they hit 60, 70 degrees, the ERP is going to back off unless you can feel it, pull the wire off, or get in the PCB, the boiler, and get it onto high rate. It's going to modulate the flow, and then you're at the other end of the house smashing hell out of the radiator with an SDS drill.
Yeah, because for the readers who don't know what we're talking about there, they do a product that you put into your drill. It's like a hammer action. It's rubber.
Yeah, an agitator. Yeah,
agitator bashes your radiator to agitate it. Now, again, it's
that corrosion can be our friend. So
it's agitating it, but the flow rate through that radiator isn't high enough to then push it to these. Now, these are big magnets. You can look them up online. What's it called, Ricky?
The main one was the original one was the Magna Cleanse.
Now, what I've seen this. I've seen engineers do this. They used to post it on Twitter years ago. But I used to work with a lecturer. He was a fantastic gas boiler engineer, like in repairing boilers and stuff. Now, when these Magna Cleans come out, he loved them because once again, you're mesmerised. You pull these big old long magnets out, and they've got stuff around them. You know, they have picked up these fine particles, but they haven't picked up nowhere near what is in that system. But it looks good. It looks very visual. And again, people are being mesmerised. But you know, you take a proper cleaner onto that system and do it properly, you'll get loads of sludge out.
Yeah. And the thing with smashing radiators with an SDS is that corrosion can be in your favour. It's masking, it's sealing the radiators, isn't it? It's a passivation layer.
Yeah.
So then you start knocking chunks of it off, and because
so we teach students in college all about. It's heavy. We teach students in college all about patinas and passivation.
Yeah.
Every different type of metal has a different patina. So copper obviously goes green, lead goes a dull grey.
That's where chemical free comes in. You create an environment and creating its passivation layer. It takes a little bit of time. Like when I done my heat pump, I give it a quick warm flush, cold flush, left it for a few days, and obviously we got orange coloured water because it's starting to corrode, and people ring me up getting a bit scared of it, and it's nothing to worry about. So with my system, we're third on a row on a lead main, so we've got pressure, but the flow rate's pretty crap. I do need to put a booster tank, so I've configured under the stairs a bit better now with the water softener. I need to get a booster in there. So we've got low flow rate but high pressure. So when I flushed it, because it was going up to the top 6-8 meters more, then back down, I didn't have the right flow rate. So you get these bins like chemical drums or Raffina plasterers buckets, put a submersible pump in it that runs about 3 or 4 bar, then you pump into the Thorough Flush, then you can bi-directional flush the system.
Yeah.
Then you've got like 120 litres of water going through and round, and then just clean it out that way. And for most new systems, you can't Magna clean a new system really, because there's no point, because there's no debris in there. Power flushing's way overkill. And even if you've got low flow rate on a power flusher, they don't work for me, because if you've got a power flusher and you're feeding it with low flow rate, you've got to keep filling the tank up and turning it off because it'll empty the tank too quick. So you've got to dynamically balance, and then you've got a power flusher with low flow rate and low pressure. So you've got to feed it from a brake tank. It gets a bit technical if you do it properly.
And of course, now we've got heat pump systems. We want these heat pump systems to last longer than gas boilers.
Yeah.
And another USP with oil. I've got customers out there, old customers. Their oil boilers still going. It's 40 years old. My dad's.
Well, that's another thing with the heat
Oil
pump
boilers
market.
last
It's
for a
all
long, long, long time. So engineers are used to kind of like servicing them properly, keeping them going, and the gas boiler industry, they've just they've just got away with it.
yeah. The thing with heat pumps, they're not. If you block one of their heat exchangers up, you're pretty screwed, aren't you? You've got to either blast it out with some high pressure flushing equipment, or someone's coming out to replace it and drain the refrigerant circuit,
Well, we got these
reblaze
new
it.
filters.
That's another. It's a sales thing, isn't it? A filter's a filter. You look at the velocity of a boiler. I bet most boilers are running at DT 5 to 10 because they've never been balanced. The majority of heating systems in the UK aren't balanced. Now we've got to make a different filter for a different unit just because it's a heat pump. They've all collect debris, but because it's a heat pump and HPF heat pump filters sell, don't they? It's a buzzword.
The filter industry is so strange. So every fluid system, whether it's gas, so the natural gas that's coming into our homes, that's filtered. That's going through filtration.
Yeah.
Every car has, your power steering has a filter system on it. Your brake line has a filter system on it. If you've got liquid fuel, you've got a filter system on it. You don't hear Jaguar or Audi going on and on and on and on about their filters. For some reason, in the heating industry, we go on and on and on about filters, and arguably they've not got them right yet. I mean, we've got these new types coming on, these backwash ones, haven't we? I mean, I don't know if
Yeah, it doesn't.
like them.
Definitely not for me. Don't agree with backwashing. If you can't pull that, if you can backwash a filter, so they're saying you've got to get them up to like 1.5 bar and then run water out them. So you're adding extra water to your system to clean your filter out and then adding more water to top the system back up. So ideally, VDI standards recommend minimal top up. So to backwash your filter, if you can backwash it, take the gauze out, possibly yes. But if you can't take that gauze out of that filter, it's definitely not for me because you can take a gauze out and then you've got to literally get it under a tap and scrub to get some of the debris out. But if you've got a gauze in a plastic vessel and some of these filters have bypasses in, so when it does block up, it lets all the crap go through anyway. I explain that one. So a filter with a bypass, so when it blocks up, it keeps the heat pump running.
It's marketing gone bananas, Ricky.
So unless you can take that gauze out and physically see it and wash it, it's definitely, I wouldn't like to fit one. And some people might because it's easy to service. You just fill the top of the system up, waz a load of water through it, and off you go. But I would like to take the gauze out and physically see what debris it's caught, and then you've got an idea what's going on in the system then.
So I'll tell you exactly what goes on. You'll have a manufacturer or an entity, they'll look around the industry, think, oh, crikey, these filters are selling, we need to make one. So it happened with inhibitors, it happened with magnetic filters, it's now happening with heat pump filters. And they'll go, oh, these are real big sellers, we need to make one. And let's make one, let's get some people to make one a bit different. So we've got a bit of a different selling point.
Yeah.
We've got some different features and benefits we can sell. And they'll come up with any crap. They'll come up with any. The engineering going on in this industry at the moment amazes me.
And you know what? I don't see what's the problem with a line strainer. So I've got a Cleffy HP XF filter in the loft. That's backwashable, but I wouldn't get the pressure up there. I'd have to. It's right at the top of the system, so to backwash it'd be a nightmare. But I do have a ball line strainer on the ball valve in the heat pump. So when I service it in June, I'll just pull the bottom off the insulation, shut the ball valve, pull that filter out, and there'll be hopefully minimal stuff on it. And I do get it from manufacturers. They're getting call-outs for flow issues, which is not their problem. So they're getting errors flagging up, and the manufacturer having to send someone out, and it's just a dirty line strainer. So a bigger gauze filter will stop that. But to me, a filter just has to be a big, low-velocity pot, nice line strain, nice gauze in it, magnet with a lid you can take off to service it. 2 isolation valves, drain it off, lift the gauze out, wash it out, back in, and off you go. So simple.
This is the weird thing with manufacturers, because manufacturers spend an awful lot of money on warranty call-outs. an awful lot of money. It's what some people have told me what that some companies have told me what they spend. Because you've got to have people in vans, you're traveling all around the country, the logistics of organising. Now, if I was a manufacturer, I'd be thinking, right, I want to reduce all that. Right, VDI 2035 is really good. Right, let's promote that. All right, these filters seem to be used by the top engineers. Let's promote them ones, and promote really good systems so that you aren't getting all these worry call outs. Now they don't do that though. They're all because at the top, at senior leadership team sort of level and beyond, above, the people running these companies aren't engineers.
No.
And I don't know. I'm not a marketing person, mate. Maybe.
You know what? The Baxi Duotech. I don't know if these 6 and 800 in on the return line on the return isolation valve. There was a line strainer about 3 inches long. You never got sludge in them boilers. The only time you'd get blocked up heat exchangers was too much scale in the water, so it'd bake on the heat exchanger, crack off when it is red hot, and get sucked into when it's on its hot water mode. It gets sucked into the plating block. So they just had a little line strainer in, and that's all boilers really need. Just a line strainer to protect them. And it's. I was speaking to a customer today. It's not the manufacturer's fault. They shouldn't. It's always the boiler or the heat pump manufacturer's blame for the shit system, isn't it? Oh, pardon the French, for the crap system. It's always them that gets called out for the first problem. Oh, this heat pump's crap.
Yeah, exactly. It's not their fault.
It's not their fault.
It's not their fault, which is why I don't understand they promote really good systems.
Yeah.
It's because they don't understand good systems yet. And that sounds a really sort of big-headed thing to say. Obviously.
You know what? I think it's getting, since obviously COVID and that, the 2020 era, Kimbo Batty launching Heat Academy, Adam and Patrick launching Heat Geek. I think it's definitely, I've seen a change in the industry. I know a lot of lads, the customers have gone from just doing gas boilers to top end installers now, like top end.
Oh yeah. I mean, that's the great thing. What we need to see,
the manufacturers are listening to them.
Yeah, they are, and hopefully some of them are going to start to put their head above the parapet. Because if they did that, you'll get all these good engineers think, "Oh, good on you for being a bit honest." And they're very influential. These good engineers. They'll say, because they help us. They're really honest about it. They've held their hands up, maybe getting it wrong in the past.
Manufacturers are. I think a few of them are listening. Like I've got going down to one on Monday to introduce chemical free to them. So they want to know about it. I think they're just worried about how they test for it. And it's like the same when you mention to them, how do you test for the inhibitor? And
you would
if the water's dirty, it's dirty.
It came out 30 years ago in Germany with the 3 big German manufacturers, Bosch, Wiesmann. You'd kind of think in the UK, the same companies that's what they promote.
But you know what? I went to Italy last week, a week before, to the MCA, and there's still a filter market in chemicals. There's not many. I think Fernox were there. There was some smaller brands, but there's still a lot of them were selling their own inhibitors, and I think they're struggling. It's all about monitoring. I keep saying to people, monitor it, system design, know your volume, add enough inhibitor to cover it. Well, the problem is we don't go back and check systems, do we?
But AD will say, yeah, well, we do monitor it because we've got a product that monitors it. And obviously
that's just testing for molybdate, pH, and iron.
Yeah, it's just testing their own stuff.
Yeah. And it's like Wolseley, AD make a Wolseley inhibitor and won't provide you with any guidance how to test for it. And on the bottle it says complies to the British standard. So how does that comply to a British standard if that Wolseley or AD won't give you any information how to test for it? So you've literally got to work out the dose rate in a jug, do some equations to lower it, test it yourself and go, right, this is 50 parts per million of molybdate. So when this system's protected, I should have 50 parts per million of molybdate. But you tell me an engineer that's going to do that, no one.
And that's where I think they've shot themselves in the foot, these chemical companies that wrote that standard, because it is actually a requirement in the regulations to test and adjust heat systems as appropriate. So that covers all sort of testing.
Yeah.
But obviously water quality being one of them. I don't think they definitely don't know how to interpret requirements from regulations and guidance. They definitely know, because if they're calling chemical inhibitors mandatory.
Well, that one from, what was it, was mandatory. Flushing's mandatory, which it's recommended. I wouldn't say it's law you've got to. No, they do say, a lot of the manuals say, like, thoroughly flush a heating system. It's just quite good that my company's called ThoroughFlush, because they all say thoroughly flush it. So that was not mandatory. Did it say reducing scales mandatory?
If anyone wants to learn anything about VDI 2035 or what the thorough flush does? What do they do, Ricky? Did you go to your website?
Yeah, there's not much information about learning on there. It is just basically a sales shop, but I'm happy to have a chat with anyone who's wants info. We are going to start training, so I've
Well, you've helped
added.
so many. Well, nearly all the guild master, the master engineers in the guild love VDI.
Oh yeah, I've got since the Twitter days, 2017, 18. I've seen a massive transition of people just going from over to heat pumps, growing the business. They've come over to me, bought the Thorough Flush when I launched, and then they're all on chemical free now.
Hmm.
And a lot of people see the benefits of it. They're going back to systems that they've Thorough Flushed and gone chemical free 6-7 years ago when we launched, and they've never had issues going back to them.
And there's customers that really, people like Mick Wall and all these customers that had their systems properly done.
Yeah,
Obviously,
yeah,
used
yeah.
to in the past when they might have seen a boiler getting drained down for whatever reason. They all
Well,
have.
I've done the podcast. Did you listen to that one I done with Mick a couple of weeks ago?
I haven't listened to that one
Yeah,
yet.
Mick invited me on the show, and he said, "Yeah, I used to have get a drain down, a boiler fitted, and then obviously Damo's come and he's like opened Mick's. Well, his Damo gave Mick a new hobby, didn't he?
Oh God, I call Mick my expert customer, don't I? And he is an expert.
Yeah, I don't know what he's going to do. What his next step is. That's probably what the podcast. He's got all his gizmos now, hasn't he?
But Mick, people like your Micks and there's lots of others. They kind of epitomise self-directed learning, and that's what all you good engineers did. Like Damon, 10 years ago definitely wasn't fitting heat pumps, and they
No,
all
no.
learn, and they did learn. Now, lots of engineers are very busy out there, very, very busy, and we've got a well-being problem. It's very stressful for people out there. So it's about finding the right way for individuals to inspire them to want to learn a little bit more. Because at the moment, a lot of them are switching off to technology. They think they're doing it right, and I understand why they think they're doing it right. Because again, they've been bamboozled with marketing. A lot of engineers out there think if they put a Magna Clean or any other filter on that system, they've done a really, really great job. They can do other great things. They can safely install a boiler. They can safely test it and commission it so it's combusting properly.
Yeah.
But there's a few things they just need to know, and it would be beneficial to everyone else if they did know them. And we've got to find some clever ways to help them because we can't go irritating them because they are doing good things in other areas. I know engineers that can walk into NHS plant rooms and get them systems going again. I mean, that's critical. And yet they still struggle with some of the science around heating. I mean, I did this thing at Nesta the other day. So I did an inaugural event at Nesta, and I invited some manufacturers and the Sustainable Energy Association there, Energy Systems Catapult were there, DESNES were represented there, and I think I had about 36 people in the room. And I have these whiteboards, these mini whiteboards, because I'm all about active learning rather than passive learning, where I just lecture and people listen. I want people to get involved, write things down, critically think about it. So I ask questions. And the first question I asked was, I said we all use standard units of measurement. We measure things. Us humans like to measure things. So the standard unit of measurement for distance is a meter. So I could have a millimeter if I'm measuring small distances, or a kilometer if I'm measuring large distance. I said, right, what is the standard unit of measurement for heat? Only 2 people could answer it. It's joules. Everyone else was putting Celsius or Kelvin. And I said, look, most of you are marketers. So I did it for marketing and comms people. I said, look, absolutely, did I not expect you to know this? And I don't want you to feel sort of inferior that you didn't know it, because I reckon over 90% of heating engineers out there don't know what the unit of measurement is for heat. I know technical directors that don't know it, and I know a lot of lecturers that don't know it. And it's a bit ironic. We're in a heating industry. No one really understands what heat is and what its difference to temperature is, which is why we've got this major, major problem with so many gas engineers that are highly skilled in getting equipment going, especially big equipment, who do think you need hot radiators. And that's the problem. They don't understand it. Most of the time, you've never needed a hot radiator. And they don't understand the relationship with heat and temperature. And I don't want to make their engineers feel inferior because that's something they haven't been taught. But there is this other side. We do need to inspire them to become self-directed learners. In an ideal situation, you want them to think, right, there's some things I don't know about this industry.
No, I think
And we've all done that. That's what we've all been on a learning journey. You did it with VDI. You for some reason thought, oh, I really want to get into this, and you've now become known as the man that everyone goes
I
to.
got through the deep end by buying it all.
Yeah, that was my fault. But
um, but
yeah,
do you know what? I think if you learn the basics and then you understand it as you're doing it, and I'm one of those engineers that it just doesn't sink in until you practice it.
mm,
Do you know what I mean? And that's what I say to people who are in the heat pump game. Fitting a heat pump at your own house is definitely a game changer
which is
because you
what
get
the
to hear at night what's going on. It's defrost. It's making a noise at this time of night. It's doing this. And
this is what this start at home thing is about with Nesta, and I've
yeah, Nesta, yeah.
got Nesta coming to speak. I mean, I've been consulting Nesta for a lot of years now, and I always sort of splurt out ideas here, there, and everywhere, and obviously people are taking notes. And I remember saying years ago, get engineers to put them in their own homes because they'll get used to. Because a lot of engineers out there, the gas engineers, are sort of poo-pooing the technology. They don't realise the technology is everywhere anyway. So many of them don't realise
Yeah.
it's everywhere. And I said, get them to put them in their own home. They can learn it, tweak it, do
You
whatever.
know what? I think the best thing to do, I'd not done it because I don't have an install company, but I think the best thing to do is we get Glyn and Tristan's fit a heat pump and get OEM.
Yeah.
And then that's your marketing tool, then, isn't it? So you've fitted a heat pump in your own house. You've got all your temperature readings, your SCOP, your COPs. That £1,000, whatever it costs for that kit, you've got that as a marketing data. Chuck it in a flyer, a brochure, a PDF, an email, and
Yeah,
that's
it's
your
what
sales.
Alex at Libtech does. Yeah, he's one of the guild engineers. He's got a lot of his systems are on OEM, and of course,
I think most people I would speak to, heat pumps don't work, but if you can prove you got one in your own home, and that's the first thing they say if you go and try and sell one, have you got one in your own home? And if you say no, why not? You're done, you're out the door.
Yeah, maybe you should give me the address of that company, and I'll go and knock on their door and say, your system optimized? £5,000.
Yeah, I was pretty gutted at like you get it with like hedge cutting, don't you? Cut your trees down to your gutters, but if it's coming with plumbers now into heating systems, it's a bit of a piss take.
It's horrible. It's really horrible. I mean,
Yeah.
it's just a bad name. We've had a bad name for a long time, heating engineers and plumbers, and yeah, there's cowboys out there. But what the main problem is, there's people out there what we call unconscious incompetent. Now, the word incompetent does sound quite horrible, but
You know what? They might do a real good job, but
they want to do good work, and they're very nice people. They just don't know that they don't know some things.
no, 1,100 quid's a lot of money in it.
Yeah, that is exploitative, and
But yeah, I say to people like I will be talking about going back to training. I'm going to start doing a bit of training, small groups, local training centre, Stirling.
what about
I've got a few colleges I'm going to be working with soon.
what about actual consumers? Do you think there's a market for consumers wanting to get on and just understand a little bit about the science of the water in their systems?
Well, I've been invited. Seisman Urban Plumbers keeps asking me to do some like YouTube, so I might, when it calms down, if it does, because I'm just busy all the time. It'd be nice to get down there and do a consumer video with him. Then obviously he's got a big outreach on YouTube.
He's a video master, isn't he? He's good.
Yeah, he's good at editing. He just knows how to present everything quite well. So, but yeah, I think consumers, it's a good angle to go at. Then they can get to see the products and what it does, and the data's there now. People have been testing. They're going back year on year, and systems aren't falling over. Sight glasses on the floor staying pretty stable. Because that's the other issue. We've got massive the amount of underfloor that's going in now. I think we're going to have an underfloor issue in a few years with all these chemicals getting put in them. So there's another product I'm working on.
That is, you've got this whole chemical industry saying biocide. You need biocide in underfloor. Well, a lot of this biocide is the problem because it's actually it's giving the food for these microbes.
We're just adding stuff, yeah. No one knows, and you can't. You gas them, yeah. It's just put it in, add a bottle of this, and add a bottle of that, and I think if you can remove the minerals, you tend. Well, I've never seen any huge amounts of bacteria. No one's ever run me and said I demineralised the system a couple of years ago and it's blocked up.
You know what would be good? I might touch out to Nesta about this. Is so obviously we've got customers having heat pump systems installed. It would be good to have some sort of trial where, let's say, some heat pump systems were installed with a particular manufacturer's product and maybe cleaned with a manufacturer's product, so we keep it all standard. let that system run for a couple of years, and then obviously compare that to other systems that are having the VDI 2035 method, and then after a couple of years, or sporadically test it, see whose systems are sludging up. Because I know for a fact which ones would be worse.
I've had customers ring me and say they've fitted boilers under the floor and had problems, and then they started using like the thorough flush, just going with mains fill or resin filling, and they've been going back a few years later and had no issues. Everything's back to normal.
Look at Mick Wall, perfect sort of candidate. He's been monitoring his system implicit, and he knows that water's way cleaner than any other water he's had in any other house.
Yeah.
I
think they're going back to fit some TRVs, aren't they, or something soon? And that's what I said. I promote like these Rafina plasterers buckets as well. If you need to drain your system, chuck it in a bucket and then pump it back in when you're finished, when you've done your remedial work, because that water's been through a process. It's gone through with the corrosion process of the radiators. Everything's stabilised, the pH, the conductivity. So chuck it back in the system. No good chuck it on the garden, then recirculating with resin again. Just get it back in there. So that's another. Yeah, I've got submersible pumps coming to the website soon. We're working with Pedrola, so people can pump back into the systems with glycol and stuff like that. That's another one, isn't it? Glycol, no one knows what that is and what to do with it or what to mix it back with and where to get it, because a lot of your distributors, bigger merchants, sell their own products now, don't they?
Well, they do. We know.
But yeah, training's the key. A bit of an eye-opening course. It's going to be. It's not going to be a science day. It's going to be a bit of basic testing, basic flushing, the do's, the don'ts, and then people can go on the little journey like they did with Kimbo's course and heat keep. You start talking to other people, other members, start learning different things. Then it's all about your own method. It's all about filling your own way, recirculating your own way, conditioning, testing your own way. Then what works for you? What I say to them is might not work for other people. Depends on your systems you're doing, how big your properties are. Yeah. Just keep it. All right, mate.
It was another lovely conversation. I've actually now got to go and help someone. They've moved house today, and I did say I'd go and help them. I'm a bit
late now, isn't it? 8:30.
Well, I'll take a bottle of champagne round, and you can.
Oh, you mean having a piss up, yeah?
Well, we'll have a drink close to the house. I think I've helped them move most of their houses. They had squatters. The last time they moved was 20 years ago, and they had squatters. And I did know, and they were part of a big sound system. And I did know a couple of them, so I negotiated with them for 2 weeks to
got them out,
get them out on the. Well, not throw them out, because obviously it could have got quite nasty with all sorts of sort of stories going on around that. But no, so yeah, they've moved again. So I said I'll come around and help them. I did help them the other day get some stuff over to the shed. But Ricky, it was a pleasure as always.
Awesome, thanks, mate.
I'll see you next week, won't I? Or are you going next week?
Yeah, I might go up, see if production slows down. We're just busy at the minute, so I'll try and get ahead of myself this week and then pop up. Newark Showground, isn't it? I've got a ticket somewhere.
Yeah.
So I'll pop up and say hello.
Okay, but you take care.
Awesome. Cheers, Dave. Take care, mate.
Cheers, Rick.
See you later.